Good morning, students. So in our last class from the exercise 6.3 chapter triangle, we complete 8 questions. So the remaining questions we have to do here. So today we have to discuss mainly 2 questions, the question number 9 and the question number 10. So now here, if you see the question number 9 and the question number 9 is given in this way, and if you see the diagram here and the question is given like in this way, in triangle ABC AMP are two right triangles, right angle at B and M, as you see in the figure mentioned. So now what we need to prove here, the first one we need to prove triangle ABC similar to triangle AMP, as well as the second one is here we need to prove CA by PA equal to BC by MP. So these 2 questions are specially we need to prove here. And here, for first of all, the first one is the triangle ABC similar to AMP. So if you see the diagram here, ABC, the diagram is this one, and another one is AMP. So these 2 triangles are we need to prove here similar. So let's start now here. So in this case, first of all, what you have to do in triangle, if you take the triangle separately, so in triangle ABC, so ABC and triangle AMP, so that means we have to write here AMP. So in triangle ABC and triangle AMP, so what you have to do here, if you see the diagram separately, if we draw ABC, where is ABC? So if we draw the diagram separately, now here you see this one is B, this one is A 90 degree, and here it is C, ABC, and another one is here AMP. So if you see the diagram here, this one here A, this one is P, and in this case it is M. According to our question, these 2 are given, isn't it? So separately we drawn these 2. Now our task is what? We need to prove these 2 are similar. So for similar, there are lots of criteria are there: side, side angle, side, and angle, isn't it? So out of these 3, anyone we have to apply here, and we need to prove these 2 are similar. So very simple. If you see, one angle is already mentioned here. This one is what? 90, as well as this one is also 90. So easily we can say these 2 angles are equal. So first of all, we have to write this one, angle ABC. So that's how we have to write here, angle ABC is equal with angle AMP. So that's how we have to write this one is AMP. Is it clear? And in bracket, the reason what you have to write here, the reason we have to write 90 degree each. This one is the reason. So both are 90 degrees, so that's why easily we can say these 2 are equal. And at the same time, if you see, one angle is common here. In this figure, if you see, for ABC or AMP, this angle A is what here? Common. So that means this angle A is equal with angle A. So that's how we have to write here, angle A is equal with angle A. And this one we have to write, the condition we have to write, this one is common. Is it clear? So now here, one angle is common, another one is 90 degrees. So if 2 angles are, if we get equal, then easily we can apply one criteria. Which criteria? Angle similarity criteria. So therefore, finally the conclusion we have to write here, therefore by angle similarity criterion. So angle similarity criterion. So what we can write here, therefore by angle similarity criterion, easily we can say these 2 triangles are similar. So that's how we have to write here, triangle ABC similar to triangle AMP. Is it clear? So this one is our first proof. I think all of you understood this one, isn't it? ABC similar to AMP. So now here, if you see the next question, so the next question is here we need to prove CA by PA equal to BC by MP. So now let's see here how can we do this one. So now from these 2 diagram, we can prove these 2 results. So now here what you have to do, again if you see the diagram, so if you see the diagram here, again triangle ABC and triangle AMP, what you have to do, again for the second one, same triangle we have to take, these 2 triangle again we have to take. Is it clear? So now already we proved these 2 triangles are what? Similar. If these 2 triangles are similar, then means one thing we know, if these 2 triangles are similar, that means their corresponding angles and the ratio of their corresponding sides are also equal. So that's why from this condition we can write easily the ratio here. So that's why we have to write, since, for the second one you have to write, since triangle ABC, already we proved triangle AMP. So in bracket you can write proof above, or we prove already here in earlier question. So in these two triangles, you say triangle ABC and triangle AMP. So these two triangles are similar. So if these two triangles are similar, then easily we can say the ratio of their corresponding sides are equal. So now first of all, if you see the diagram again, so ABC, so this one is A, here it is B, here it is C, ABC. Already we proved angle A and 90 degree we proved. So another one is here, if you see this one A, here it is M, and this one is P. This one is 90 degree and it is common, already proved, isn't it? So now from here you say, how can we write down the ratio here? Ratio of their corresponding sides in it. So now here angle A common, B is equal to this M 90 degrees. So that means ultimately the third angle is which one? C is equal to P. Easily we can say. So no need to write this, we need the ratio. For ratio, what you have to do? Just you have to identify first of all. So here one angle is common here, another one is 90. So in between these two angles, the included side is which one? So obviously the AB, isn't it? Remember this. One angle already we proved, this one is A equal to A and 90 degrees 90. So that means in between these two, the included side is AB, as well as here it is one angle and 90 degree is here. So included side is which one? This one. So when we have to write down the ratio, so always we have to identify the included sides here. Is it clear? So if you identify the included side properly, then easily you can write down the ratio. So now in this case, when we have to write here, therefore ratio of their corresponding sides are equal. Ratio of their corresponding side means the first one we have to write AB divided by AM. AB divided by AM we have to write is equal to. Is it clear why it is AB equal to AM? Because here common angle 90 degree, included side common angle 90 degree, included side. So that's why we have to write AB by AM. Clear? Then next one is here, if you see the opposite of 90. The opposite of 90 is what? AC, or we can say CA, isn't it? And the opposite of 90 is what here? AP, or we can say PA. Meaning is same. So if you write here AC or CA, CA by PA. You see this one. I think all of you understood this one. Which one? CA by PA. So the opposite of 90, the opposite of 90. And the remaining side, which one remain here finally? The third side remain here, BC, and which one remain? MP. So this one equal with BC by MP. So in this way we can identify the ratio of their corresponding sides. Is it clear? I think all of you understood this one. So again, if we repeat one more time here, AB by AM, because included side, then opposite of 90 is CA, and here opposite of this 90 is PA. So that's why we write CA by PA, and finally the third side remain here BC, and here remain MP. So that's why we have to write this one, BC and MP. So now from here, what we need? So what we need? So the remaining part, whatever we need to prove, we have to write from here. Is it clear? So in this question, here we need to prove CA by PA equal to BC by MP. So we need CA by PA equal to BC by MP. Isn't it? In question, sometime given in this also, AB by AM equal to CA by PA also we need. Is it clear? So if you need this one, then you have to write this. Otherwise, you have to write this one. Here actually we need this part. So that's why we have to write here CA by PA. So CA by PA equals to, we have to write here BC by MP. Is it clear? So this one is our proof. I think all of you understood this one, isn't it? Okay. Now the next question is question number 10. As you see here, the figures are mentioned, as well as the question is also given here, and the question is given like in this way: CD and GH are respectively the bisectors of ACB and EGF such that D and H lie on sides AB and FE of triangle ABC and EFG. So here you see the diagrams are mentioned, respectively. So one more condition is given here, triangle ABC similar to FEG. So these two triangles are similar mentioned here, and as well as what we need to prove, we need to prove three questions, CD by GH equal to AC by FG, and second one is GCB similar to HGE, and the third one is GCA is similar to HGA. So first one, if you see the CD by GH, AC by FG, that means here the ratio is given. So if you see the ratio here, CD by GH, AC by FG, that means these two triangles. So the ratio of the triangles are given of these two, is not it? So that means what we have to do here, how can we proceed here the question? So what you have to do, first of all we have to check out which angles are given or which ratios given, we have to identify. So in this case CD and GH given as well as AC and FG given. So that means in this case we have to take these two triangles. Is it clear? We have to take these two triangles. So if we prove anyhow these two triangles are similar, if we prove these two triangles are similar, then easily we can say the ratio of their corresponding sides are also equal, isn't it? So for that reason we have to take these two. And before this, one more condition is given here, triangle ABC is similar to FEG, already mentioned in the question. So first of all we have to write these two. So what you have to write here, given, in this case you have to write given triangle ABC. So triangle ABC similar to triangle FEG, this one is mentioned. So these two triangles are similar. If these two triangles are similar, therefore the corresponding angles are also equal. If corresponding angles are equal, that means we can write here angle A is equal to angle F. So that's why you have to write this one is angle A is equal to angle F. Is it clear? And angle B is equal to angle E. So second one you have to write here, angle B is equal to angle E. And the last one is angle C is equal to angle Z. So that's why we have to write this one is angle C is equal to angle Z. So according to our question, triangle ABC similar to FEG already mentioned. So that's why these three angles are here equal. We know according to our similarity criteria. We know this one. So now what we need to prove? First of all, our task is we need to prove these two triangles are similar, then we get the ratio of their corresponding sides. Now one more thing here given, you see CD is what? The bisector. If CD is the bisector here, then these two angles are how much? These two angles are equal, isn't it? So now again if you see here, GH is what? The bisector. If this one is the bisector, then these two angles are here equal. So we have to arrange this result here in place of angle C. In place of angle C, we can write either 2 times of ACD or we can write 2 times of BCD. Can we write? Yes, because the sum of these two angles is equal to C, isn't it? And here CD is the bisector. If CD is the bisector, that means these two angles are equal. So we can write 2 times of either this one or 2 times of either this one. Any one we have to write. So but here we need this portion for the first proof. So that's why we have to write 2 times of ACD. Is it clear? So in place of angle C, we can write 2 times of angle ACD. Is it clear? As well as we need this result, GH is the bisector. So easily we can write FGH. So in this case, in place of G, we can write 2 times of angle FGH. Is it clear? So if you want here in this side, inside you can write, since what you have to write, CD is bisector and GH is also bisector. If bisector, in place of angle C, we can write 2 times of ACD or we can write 2 times of BCD, as well as 2 times of FGH or 2 times of EGH. But here we need this portion ACD and FGH, so that's why we have to write these two. And from here we get angle ACD equals to angle FGH. This one we get. Is it clear? So now if you see here ACD is this one, ACD, FGH, this one. These two angles are equal here, as well as one more angle we know, angle A is equal to angle F. isn't it? So if two angles are equal in a triangle, so easily we can apply the angle similarity criteria, and from this angle similarity criteria easily we can say these two triangles are similar here, isn't it? So for this, what you have to do next, you have to take these two triangle. So if we take these two triangle here, you have to write in triangle ACD, and second one you have to write triangle FGH. So if you see the diagram here, ACD, so this one is A, here it is C, this one is D, and FGH. So if you see the diagram, here it is F, this one is G, and here it is H. Now angle A is equal to angle F, already we know, as well as we prove here ACD is equal to FGH, isn't it? So that's why here we have to write here. So this one you have to write angle A equals to angle F. So in bracket what you have to write? Proved above. Already we proved here, so that's why you have to write in this here, proved above, or if you know then no need to write this, and as well as ACD, angle ACD. Angle ACD is equal to FGH. So that's why we have to write here angle FGH. This one we have to write proved above again. So now here, if these two angles are equal here, what we can say? If these two angles are equal here, so therefore by which similarity criteria? Therefore by angle similarity criteria. Similarity criterion, we can write here these two triangles are similar. So that's why we have to write here triangle ACD similar to triangle FGH. Is it clear? So by angle similarity criterion, easily we can say these two triangles are here similar. I think all of you understood this. So if these two triangles are similar, then the ratio of their corresponding sides are what? Equal. So if ratio of their corresponding sides are equal, then what you have to write? If you see here, one angle we prove this one, another one is this one, isn't it? So we proved angle A is equal to angle F, as well as ACD is equal to FGH. So now here in this case you see the included side is this one here, the first one, as well as here this one. Included side is this one, isn't it? So now in this case what you have to write? AC by FG, isn't it? So now here if two angles are equal, then the third one is automatically equal. So for better understanding, if you mark like in this way, three lines. So now here you see first angle, second angle, third angle. First angle, second angle, third angle. So in this case what we have to write? AC by FG. Then we have to write CD by GH. And we have to write AD by FH. Isn't it? So if these three conditions are, if we write, and from here the required result whatever we need, we have to write down the final one. Is it clear? So I write here after this step you have to write what you have to write. We have to write here AC. So this one you have to write AC by FG. Is it clear? Equals to ratio of their corresponding sides. So that means CD by GH. So this one you have to write here CD by GH equals to, the last one is we have to write AD by FH. So this one you have to write AD by FH. So this one you have to write AD by FH. Now here after writing this one, ratio of their corresponding sides, so that's how we get here. So we get this result. So now from here, whatever we need according to our question, whatever there asks, we have to write the final result from here. Is it clear? And what we need there? We need CD by GH, AC by FG. So CD by GH we need, AC by FG we need. That means we need these two results to prove. In exam, these two also given to you, isn't it? So finally what you have to write? Therefore here we have to write AC by FG is equal to CD by GH. This one actually we did here, so finally we have to write this one. So this one is our first proof. Is it clear? I think all of you understood this one. So main task is what? We need to prove the triangles are similar, and if the triangles are similar, then the ratio of their corresponding sides are equal. Easily we can prove here. Is it clear? So now here, today we have to stop here. because already one question we have done, and the second question, the first part we have done here. So the remaining part we have to do in our next class, the question number, that means the second and the third. Is it clear? So practice these two properly, and if any questions still remain here, some doubts if remain there, then you can ask me. Then again we have to repeat this question in our next class. Is it clear? Okay, thank you.